question. The first question gives you a particular short code and it is asking you that which one of the following expressions when placed in this blank, this above, will not result in a type checking error. So a type checking error occurs when the call to a function is not matching with the actual definition or declaration of the function in this case. Okay, so basically in the code we have a function declared as f, which has the parameters int and short, and the main function has a variable I, integer variable I, value 100, another variable s which is short in nature and it has a value 12, and a pointer to a short variable which has the address of s. Okay, and now we have to tell what should be the correct call or the correct format of the call to the function f. Okay, so since f contains int and short parameters, or the type of the parameters should be integer and short, so the corresponding call should also adhere to it. So out of the four options that we have been given, we'll check and see which is correct and which is wrong. Now coming to the first option, A option states that the first parameter that would be passed is s. Now s has an integer, has the data type of short. So if we pass a data type short to an integer data type, it will be acceptable to some extent if automatic type conversion is happening by the compiler, because an integer is a larger data type as compared to a short type. Okay, or they are somewhere equivalent to each other. So this particular data types for the first parameter would be acceptable. Now coming and comparing the second parameters and their data types, we see that the second parameter is star of s. Now s is a variable of the kind short. It is not a pointer variable. We can only dereference pointer variables like this. Okay, so if we have a pointer variable p and a variable s which is of short kind and p refers to s, then star of p would tell me what is the data of s. So if s contains 10 and its address is 1000, okay, so p would contain the address of s and star of p would give me the data that is contained in s. But we can only dereference p if it is a pointer to a variable of the correct data type. Here s is not a pointer, so we cannot dereference it like this and pass it. So this is incorrect. This is not the right way of passing parameters or calling the function. Coming to the second option, I equal to f of I comma s. Now I is an integer. Okay, so we wanted an integer in the first place, yes, it is there. In the second parameter, we have s. S is short, so yes, we have the short data type in the second place. Now, the return value of f is being assigned to I, but you must notice that here f has been declared as having a return type of void. That means it does not return anything. So we cannot have an assignment to an integer variable here because f has a void type or void return type. So it won't return anything and we cannot assign it to an integer variable. Coming to the third option, f of I comma star s. Again, star s is not correct. You don't even need to check the first option, even if this option is correct, because I is an integer and we needed an integer, but star s is not the correct way of dereferencing a normal variable. Okay, so this is not possible and it is incorrect. Now coming to the last option, f of I comma star p. I is an integer, so it is perfectly valid. Star p is possible because p points to s and star p would give me the value of s. That means a variable or a value having the data type of short. So yes, First is integer, second is short, and this is acceptable. So D is the correct option here. So this was a pretty easy question. Now coming to the second question, we have the following function computes the maximum value contained in an integer array P of size n, and n is given to you be greater than or equal to 1. Okay, you are given a particular function and you have to find that what is the missing loop condition here. This condition you have to specify what would be the right condition to be written here. Now basically this function computes the maximum value of an integer array, and how it is working, it at each iteration it is comparing two values, and if a certain value is greater, it is incrementing one of the pointers, and otherwise it is incrementing the second pointer. So basically if you are given an array, I am writing a dummy array like this. You have two variables a and b. A points to the start of the array and b points to the end of the array, n minus 1. So at every iteration inside the while loop, if the value of a is less than or equal to the value present at point b, then a would be incremented. That means you would shift a right side. Okay. Otherwise, if the value present at a is not less than, it is greater than b, then instead of shifting a, you shift b. Now you have to tell that what should be the right loop condition, so that when the comparisons are done and the pointers or the variables a and b are changed, then they give the correct result at the end. That means p of a at the end returns the maximum value. Okay, so now considering all the options one by one, just like we did here, if we put the condition a not equal to n, so suppose I have an array, we'll use a dummy array to illustrate if these conditions are right or not. So if we get an example that contradicts or that does not work for any suppose this condition does not work for a particular array, then since it contradicts a particular example, it won't be the perfect condition here. Any condition that has to be written here must be valid for all types of arrays and values of that array. Okay, so let us take some random arrays and find out if any of these condition or which of this condition is being satisfied. Now in the first case, I am taking an array, suppose 12, 9 and 1. This is a array having 3 elements. So n, the value of n here is 2. Sorry, the value of n is 3. So the condition that I need to satisfy here is a not equal to n. That means a not equal to 3. That is the condition that will be checked every time in the while loop. So let's see if it is correct, it demonstrates the correct working or not. So initially when I enter this max function, the value of a is equal to 0. That means a points at index 0 and b points at n minus 1. Currently my value of n is 3, so b points at the second index. Okay, so if I use this condition a not equal to 3, so in this case a is 0 and it is not equal to 3, yes, I'll enter the loop if value at a is less than equal to value of b. Since value at a is 12 and at b it is 1 and it is not less than 12 is not less than 1, so we'll enter the else loop and execute this statement, which is b equal to b minus 1. So in the next iteration, the values of a would be 0 and b would be decremented to 1. Now I execute the loop again. First of all, I check the condition, is a not equal to 3? Yes, a is 0. So I'll enter the loop. The value at a is less than the value at b. 12 is less than 9? No. 12 is greater than 9. So I again decrement the value of b and now both a and b point at 0. So I come again to the loop condition. Since a is still not equal to 3, I check if value of A is less than equal to value of B. Yes, both the values are equal, so I increment A. So A would be changed to 1 here, and I come out of the loop and check again. This would continue as long as A is not equal to 3. In the next case, we'll again check if 9 is less than equal to 12, because A is at 9 and B is at 12. Yes, it is less than equal to 12, so I'll again increment A. Okay, now again an iteration will be run, and you'll have to see that is the value at A less than the value at B. Yes, it is less than, so A would go out of bound. A would come out to be, the value would become 3 here. Now when you enter the loop and check this condition, A not equal to 3, this condition would be false. So you would come out of the loop and return the value present at A. A has become 3, so 3 is not a valid index for this array. So this is not the right condition, okay, because you can never access a position that is you can never access an index that is not a valid part of an array. Okay, so this is not the right condition. Here similarly, for the second condition, if I draw the array and have the elements now in increasing order, say 1, 9 and 12. Now the indices are 0, 1, 2. Initially A points here at 0 and B points at 2. So my condition is B not equal to 0. Yes, B is equal to 2. I enter the loop. Since 1 is less than 12, so I increment A. In the second iteration, A becomes 1 and B is at 2. Since B is not equal to 0, so I again check since the value at A, that is 9, is less than the value at B, which is 12. So I again increment A. A and B now become 2 again. Now I further check the condition. This condition is now that I am checking is not B not the condition that I am checking is B not equal to 0. Okay, so yes, B is not equal to 0, and I check if value at A is equal to value at B. Yes, so I again increment A. Again the value of A goes out of scope, it becomes 3, and when I go in the loop, the value of B would not be 0 here also. So this would continue, and again I would return at a point where I have to access an array position that is out of bound, because A has gone to the value 3. So this is also not a correct condition. Now coming to the third condition, here I use another array. Say I jumble up these elements and I use 9, 12 and 1. The indices are these. In this case, A is initially 0, B is this. So since this condition is true, B is greater than A plus 1. So B, that means 2. 2 is greater than 0 plus 1. That means 1. 2 is greater than 1. So we'll proceed. Is the value at A less than value at B? Value at A is not less than value at B. So I'll decrement B. B now becomes 1 and A now becomes 0 as it is. Now I again go into the loop and check this condition. This condition says that is 1 greater than 1? No. So I'll come out of the loop and I'll return A. A is not the maximum element here. Okay, since it is a valid index, I will be able to return the value 9, but 9 is not the maximum, the actual value that was intended out of the function. So these three conditions are wrong, and the correct answer would be this. You can actually fit these conditions in all these arrays or any kind of array, and you will find out that the correct condition is this, and it will work for all cases. So basically what this condition is doing, it is taking up any array, or I can say a longer array, and it is moving A ahead and moving B ahead depending upon this comparison, and it is comparing, or it is making these such comparisons till a point when B and A become equal. And when they become equal, it is stopping and coming out of the loop and returning the value that is present at the index A. So I hope with these examples the question is clear to you. However, if you have done or practiced more questions, in one instance it will be clear that this is the right condition. If you are moving from two opposite directions and comparing elements, then we have to move till one of them is not equal to the other. We'll be solving the second question first today because it is a little easier than the previous one. So let's get started with this and finish this, and then we'll continue with the first one. So in this question, you have to tell the output of the program. There is a variable m whose value is initially 10. Then there are two declarations n and n1. N is assigned the value of plus m. Now plus m means it is a pre-increment operator. That means first m will be incremented, the value of m will be increased, and then it will be assigned to n. So n gets a value of 11. Now n1 is equal to m plus plus. That means n1 is assigned the value of m, and then later the value of m is increased because it is a post increment operator. Post increment means assign the value of the variable first or use the value first and then increment this value or change the value. Now using this expression n minus minus, the value of n is decremented. Minus minus n1, again the value of n1 is decremented. Here post decrement and pre-decrement do not make a significant difference because they are not being used in any expression or any assignment. So either we do post decrement or pre-decrement, it is making the same result. Alright, now n minus equal to n1, that means n is assigned the value of n minus n1. So n is assigned the value of 10 minus 10, which is 0. So printf %dn, and this value comes out to be 0, as you can see here, right? So the result is 0. So it was a little easy question. You need to know the concepts of post increment, pre-increment, and post and pre-decrement operators and how they are changed and used in an assignment expression especially. All right, so now coming to the first question. The first question has a function and you have to find the time complexity of this function in terms of theta notation. All right, the question has two for loops. The first loop uses variable I from 1 to n minus 1, from 1 to n, and it increases by 1 in each increment. And the second for loop starts from j equal to 1, goes till n minus 1, and it increases by amount I. Now this is the most important question, the most important statement in this question, because it is not j plus plus. It is not increasing by the same amount every time. It is increasing by the amount I. So when I is equal to 1, the value of j would vary from j equal to 1, 2, 3 and so on. When I is equal to 2, the values of j would start from 1, then 3, because the increment would be j plus equal to 2, then 5, then 7 and so on. And similarly I equal to 3 would make j go from 1, 4, 7 and so on. Alright, so basically we can say that in the first iteration, or when I is equal to 1, the loop, this inner loop will run around n minus 1 times. Because of this condition, j is less than n, so j will be incremented by 1 each time and it will go till n minus 1. When I is equal to 2, j will make the jumps of 2, so it will be running approximately n minus 1 by 2 times. In case of I minus 1, this is the number of times the inner loop would be running. Alright, and I can approximate it to n by 2 times, because n by 2 provides an upper bound on n minus 1 by 2. Similarly, in the case of I equal to 3 and so on, you can find out that it will be running n minus 1 by 3 times, which is approximately equal to n by 3 times. Alright, so if we sum up all the iterations, and actually we have to find out how many times this inner statement printf will be executed. It will be executed the number of times the outer for is being executed multiplied by the number of times each of the times the inner for is executed. So basically it will give us the summation of these two, because these all values till I becomes equal to n. Alright, so in the first iteration j will be running n minus 1 times, plus for the second iteration n by 2 times, plus n by 3 times, and so on. So if I sum all this up, I would be getting n. I am approximating this to be n plus n by 2 plus n by 3 and so on till the time I get a increment of n. That means the value of I is equal to n, then j would jump by n in each iteration of the inner loop. Alright, so if we take n as common, the value comes out to be, or the sequence that is formed, it comes out to be like this. And you can say that this series approximately equals to log n. You can either remember it, or if you remember the series of log n, you would know that this series is approximately equal to log n, or it provides a theta bound. Okay, so this can be written as theta of n multiplied by log n. So this was an easy explanation for this answer or this question, that how would you find out the time complexity in terms of theta notation, in which you are given two for loops, one out of which is incrementing, or the control variable of the inner loop is incremented by the amount depending on the outer for loop. Alright, so the main thing that you have to remember in such questions is how many times each loop is iterating, or how many times it is running. And in finding the complexity, you need to know major round out values or upper bounds on some series. Like one of the important series was this one, so it always has a runtime of around log n. Alright, so it becomes n log n, theta of n log n. So that's all for today's lecture. I hope you have an understanding of both these questions. Please mention in the comment section below how did you find the video. Like this video if you understood the questions, and share it with your friends, and don't forget to subscribe to the channel of Easy Engineering Classes and hit the bell icon to get more notifications on our upcoming videos. Thank you for watching. Good luck.